Today we're going to be doing a question from the 2004 Form B AP Calculus test, and it's question number 5. This question says, consider the differential equation dy over dx equals x to the fourth times y minus 2. In part A says, on the axis provided, sketch a slope field for the given differential equation at the 12 points indicated. So right here we have the slope field with the 12 points indicated, and I wrote out the coordinates of each of these points. So to find the slope, we know that we need to just plug in each of these values into the equation. So for the first one, we plug in -1 for x and 0 for y, and that will give us a slope of -2. And for the next one, -1 for x and 1 for y will give us a slope of -1. So let's go ahead and do that for the rest of these points, giving us 0, 1, 0, 0, 0, 0, -2, -1, 0, and 1 for the slopes, respectively. So now that we've found all the slopes, just by simply plugging in the x and the y value from each of the coordinates into the differential equation that's given, we can find the slopes at each of the points specified on the slope field graph or plane that they gave us. So now that we found the slopes, let's go ahead and graph the slopes on the axis with relative steepness given to each of them. So at -1, 0, we have a slope of -2, which is in the negative direction, and it's fairly steep, so we'll go ahead and do that. The next one is -1, also in the negative direction, but slightly less steep. And at -1, 2, we have a slope of 0, so a horizontal line. At -1, 3, we have a slope of 1, so we're switching to a positive slope, so opposite direction. At 0, 0, the slope is 0, so a horizontal line, and that's the same for at 0, 1, 0, 2, and 0, 3. At 1, 0, our slope is -2, and then at 1, 1, our slope is -1. At 1, 2, our slope is 0, horizontal line, and at 1, 3, our slope is 1. So now that we went ahead and we graphed the slopes that we found, we can see our slope field as given, which is pretty simple to find. So let's move on to part B. Part B says, while the slope field in part A is drawn on only 12 points, it is defined at every point on the xy plane. So we need to describe all points on the xy plane for which the slope is negative. So for part B, we know that the differential equation is dy over dx is equal to x to the fourth times y minus 2. So to find the y values that will give us a negative slope, we're going to put y minus 2 is less than 0. Since it's a negative slope, we know that it's going to be less than 0. And let's solve for y, so we know that y is less than 2. So those will be our y values. And then for our x values, if we do the same by putting x to the fourth is less than 0, we just get x is less than 0, which isn't necessarily true. So we have to use a little bit of critical thinking and looking at the graph to determine that the limitations for x value are simply x is not equal to 0. We know this because the only time at which a value for x will influence the slope of the line is when it is 0, because x, or 0, plugged into x to the fourth, will give us a value of 0, making the whole slope 0 and therefore horizontal. But if we were to have a negative value of x, we would end up with a positive value since x is to an even degree, and we know that something such as a negative value, or -1 for x, if we plug that in, would just give us 1 once you put it to the fourth. So we can simply say that the restriction for the x values is when x is not equal to 0. So to put this into clarifying statement, we can say slopes are negative at points x, y, where x does not equal 0 and y is less than 2, which is going to be our answer for part B. So part C, part C asks us to find the particular solution y equals f of x to a given differential equation with the initial condition f of 0 is equal to 0. So on part C, we're finding the particular solution. So we know that we're going to use the antiderivative to find the original function of dy over dx is equal to x to the fourth times y minus 2. And it gave us the initial condition, which says that the points that we need to plug in for the particular solution are 0, 0. So let's go ahead and get everything that has x's onto the right side and everything that has y's onto the left side. So to do this, we'll multiply both sides by dx, which will effectively cancel that out, and we'll divide each side by y minus 2, which is the same as multiplying by 1 over y minus 2. And therefore these will cancel out. And to tidy this up, we end up with 1 over y minus 2 dy is equal to x to the fourth dx. So now let's go ahead and find the integral of both sides, and then we can plug in our particular solution point, which is right there. So we know that when we have something such as this on the left side with y, that the integral of that will be the natural log of the absolute value of the denominator, which is y minus 2. And for this side, we know that it will be x to the fifth over 5 plus c, which is very important. We need to add the constant because we always add the constant on the side with the dx. So let's go ahead and get rid of the ln on this side by raising both sides to e. So when you have e to the ln of anything, we know that we can cancel this out and bring this part down. So we end up with y minus 2 is equal to e to the x to the fifth over 5 plus c. And on this side, using our knowledge in algebra, we know that we can split it up into e to the x to the fifth over 5 times e to the c. And we know that e to the c is going to become our constant, so we can just replace this with a letter representing our constant. In this case, we'll make that k. So we know that e to the 1/5 times x to the fifth is equal to y minus 2. So let's go ahead and plug in our initial condition values of x and y to find our value of k. So we know that 0 minus 2 is equal to e to the 1/5 times 0 to the fifth times k. And we know that anything to the 0 power is going to be 1. So we have negative 2 is equal to 1k. So negative 2 equals k. So let's go ahead and plug this back into this equation and set it equal to y. So we know that y minus 2 is equal to negative 2e to the 1/5 x to the fifth. And let's go ahead and add 2 to both sides to make it so that it is y equals negative 2e to the 1/5 x to the fifth plus 2 for our final answer to part C of the 2004 Form B question number 5.